Okay, so today we will discuss about how to model a geometry in which we want to work on it or we want to study it. So we will start from the scratch. So first I will check here in this software that whether we have some basic structure or not. If not, then we can find in the Google the CIF of the required material which we are going to study. So, for example, let's start uh, here. I will just take as an example. So, for example, I am here taking this silver bulk structure. Okay, so this is the silver bulk structure. So we will first go to the display and select ball and stick. Okay, here make it uh, more visible. So now you can see this is the conventional unit cell or bulk structure where you can see that these are the latest parameter. So this is a simple cubic structure and you can see that in symmetry constraints A equal to B equal to C. And you have also in the angle section you can see that alpha equals to beta equals to gamma. So uh, let me show you. So first we will go to the build. In the build we will check this symmetry. So here you can see that all the information about this structure. So whatever you want to do with this, you can do it. So how this conventional unit cell is made? So basically it is made from the primitive cell. So here you can see that this is the primitive cell of the silver uh, simple cubic structure. Okay. And here the latest parameters are 2.88 something, and the angles alpha equal to beta equal to gamma is 60 degree. So this is the primitive cell configuration. Okay. Anyhow, we are not interested in the primitive cell configuration, but uh, if I want to cell, if I am interested to work in the unit cell or the bulk structure, so here you can see that. Let me show you that. So here what I am going to do is that I will save this structure in the PDB format, and here I will mention the structure so that I can see this. And this structure is I can easily find. Here you can see when I export it, so you will find that in the export, here I will see this page lecture. Where okay, here you can see this one. This is the structure which I just saved it. So here you can see that here it has only just one atom. Here you can see, and without the latest parameter or the periodic cell. Okay, boundaries. So anyhow, this also represents the same structure, but if I am not interested in single atom, and I am this single atom also represents the unit cell actually. So if I'm not interested and I want to save this unit cell as it is, then I need to make it. Here you can see we will go to the build symmetry, and here I will show it. Make it a P1. Okay. So here you see that all the invisible like the B and C were invisible, and the gamma, the angles are also were highlighted. So now it is, when I make it P1, then you can see that the angles appears clearly. So you can modify it even. Now if I save this structure, again export, and I just save it as AG, and I will write it with P1, P1 structure, lecture, pdb. In the same structure I saved in this format. So here you can see that, here you can see this is saved as GP1 lecture. So now I will bring it here again, and here you can see the difference. Okay? So here now you will it will be saved as the structure was, okay, and it appears in the unit cell structure. Okay? So here, so this is another method, like if you are interested in the actual structure, okay. And if I now, okay, let me show you the PDB file. So in the PDB file, sorry, in the PDB file, open with WordPress. Here you can see that in PDB, the coordinates and there are some other symbols, okay, and angles and everything is there, but I don't need this. I just need a simple coordinate file. So then you must have either Vista to be installed or VMD. Okay, so I will just bring that PDB file, this AGP1 lecture, to this Vista. Here you can see. So this structure and your Material Studio structure, the actual this one. Here you can see. So this is the same. Here, can you see this? Here you can see. So this is the same as it appears. So in here it is also the P1 or the bulk structure, and here, sorry, we made it P1, so it is not a bulk structure. And here it also shows the same with the cell boundaries. Now I will export this, export data, and I want to save this structure as a XYZ file. So I will save it. And here in the Vista, it shows that do you want to save the hidden atoms too? So we don't need to do that. So I will click on no. And then I will open this file. So here you will see. Yeah, open with WordPad. Now you see, I just only get coordinates. But here you see that we had only 4 atoms, but here it shows the hidden atoms. So this means that I don't need to open this structure in Vista, but I will open in the VMD, because we know that this atom has only 4 atoms. Here you can see that if I click it here, here it will show you uh, the number of atoms here. Number of atoms equals to 4. Here you can see this one. So I know that this it has 4 atoms. So I will open this structure in the VMD, and here of the graphic, if I want to visualize uh, for confirmation actually. Okay, so here if I want to get the sphere resolution, I should increase so that it should be perfectly sphere. Okay, so this is just for when we are interested to uh, plot this. Sorry, to take the picture of this figure. So anyhow, now I will save this to save coordinates and select XYZ, and I will write the name. So AG P1 lecture, and in Vista we made lecture 1, but here I will write with VMD dot XYZ. Okay? So I said that, and now I will open this file. Let me check that whether it has correct number of atoms or not. So sometime you need to be very, not sometime, always you need to be very, very careful that whether you know what number of atoms your software, your structure had, and what kind of, how many number of coordinates or positions the visualization software give you in return. So this is, here you can see that VMD created the correct structure in XYZ, transform the PDB file into XYZ file, and then it has 4 silver atoms. So I will take these coordinates, and now whatever software I am using, whether it is Gaussian, it is KSTUB, or it is Siesta, or it is Win2K, it is QCAM, WASP, whatever. Okay. In Vista, Vista has the ability to create your WASP in-car file. Here you can see postcard, sorry, not in-car, postcard file. So this is my actual structure, and here you can see when I click here, export data. So here you can click, and here you can see that WASP postcard. Can you see this here? So you just give the name, and it will write this file in the WASP format. So I am writing WASP. Okay. So okay. Here it is asking that whether you need fractional coordinates or Cartesian coordinates. So it is up to you. I am selecting Cartesian coordinates, and here you will see that the file is created, and that file should be in the WAS format. Okay, I just made a mistake. Instead of WAS, I need to write this, and this one I will delete. Here I will write export data, and here I will write postcard. Okay. So fractional coordinates are Cartesian, so I select Cartesian, and now you can visualize this one. Open it here. Either you can open it in the notepad or wordpad. So here you see it automatically creates the latest parameters, okay, and the Cartesian coordinates. So this is the VAS format postcard file, which we call input file actually. Okay, so this means that when you create structure and in any format, then you need to basically when you are taking the coordinates, so if you need directly PDB or any other format, you can utilize that. But if you need the XYZ coordinates and that is in Cartesian, then you need to be very careful that which software is basically giving me the correct coordinates, not more coordinates like as we see in the Vista case. It created in the XYZ format. It creates 14 atoms, which we do not require. Actually, in our system, it does not have the 14 atoms. It has only 4 atoms. So the same way, then the same file I visualize in the VMD, and VMD gave me the correct 4 atoms coordinates. Okay, so this is what we are actually doing. So you need to be very careful about transforming the coordinates and uh, so here I showed you that what is P1 structure, and if you directly save it to PDB, it will only give you one atom. Okay, but that one atom also represents the unit cell or the bulk structure, and if you want the correct number of atoms as it is showing in the material in the unit cell, then you need to make it P1. Okay. In the next lecture, I will show you that how we can take the supercell or the planes which we are interested 100 plan, 010 plan, 011 plan, or negative, positive, whatever plans you are interested. So how you can make it. So I will show you in the next slide. Thank you very much.